Thank you for coming to my talk, Best Practices for Developers to Master Security. I'm Maciej Mensfeld. I'm a creator of a platform called Defend. After it got acquired by WhiteSource, I joined WhiteSource as a senior product manager for supply chain security. I'm not that heavily involved in JavaScript ecosystem. I am involved in JavaScript security, but I'm not a JavaScript programmer myself. And I spent half of my life contributing to various open source projects. I came here yesterday from Krakow in Poland. It took me 14 hours. And I spent 2 additional hours at the customs because I didn't know if they're going to let me in because I didn't fill up a form because I'm not the best in reading CDC documents. They let me in because I had a visa that was required before Poland joined the non-visa transportation agreement. And because I had it, they let me in. Otherwise, I would be now, flying back. I figured that out when I was flying here, somewhere in the middle of somewhere here. My friend pinged me, because with Lufthansa you have internet, and she was like, man, did you fill that out, this form that you need to fill at least 72 hours before you fly here? And I was like, no, because I bought the ticket 48 hours before I flew here. And I didn't know what to expect. But as you can see, I'm here. Today we're going to talk a bit about security, what it is, why it actually should matter, whether you do backend or frontend or both or nothing. I'm going to show you some of the risks, threats, recent incidents in the JavaScript ecosystem, and some attack vectors. I will try to give you some guidance on countermeasures and best practices. And if we have enough time, I'm going to mention some of the legal stuff that will happen in the upcoming years. I hope that after this talk, you'll get a bit of knowledge and understanding that software security shouldn't be taken lightly. I noticed after talking, especially with front-end developers, that they're like, no, it doesn't affect me, it's just the back-end stuff. Browsers are pretty well designed, they have really good sandboxes, why should I worry? Well, I hope you're going to understand why you should. And you should get a bit of knowledge on how to countermeasure some of the problems because of, with some of the best practices I'm going to give you. Few disclaimers. I specialize in open source supply chain security that is part of supply chain security. As I said, I'm not a JavaScript expert, though my examples come from JavaScript, from NPM especially. And it's a really wide topic, so if you want to talk more about it after the talk, just get me a beer during the after party, and I will be more than happy to talk about that and other things, depending on how many beers you give me. So just a vague definition of security. Computer security, blah, 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 is about protection of your software, hardware, and your data. Long story short, right? You can read more at the Wikipedia. So let's just jump to more interesting stuff. Why it should matter? It should matter because everything is moving to the web. Web applications are more widely used than ever. And there's this new realm of IoT applications that just expose APIs as well. Modern software stores a lot of data. Data is the new oil, and there's this notion of not removing anything ever. So the more data you accumulate, the more risks you put on yourself. Majority of your software is anyhow going to be built with open source blocks. A single big incident can break a company. So it's really good to keep that in mind. And I hope you like your data because you may lose it. So if you cherish your data, and especially if you're like bring your own device type of person, you need to be really cautious. The good thing though, and I know it's the same with JavaScript and Ruby, that modern frameworks take care of a lot of problems. They, SQL injection, CSRF, and other things. They're pretty, the standard generalized things are pretty much tackled by toolings. And we know that, but also malicious actors know that, and they're becoming more and more aware of this and new attack vectors that they can use. So they build up portfolios of ways of attacking companies. Today, I want to focus more on things that can affect you directly during the development process. So I'm not going to mention that many things production-related. I'm maybe going to mention some CI/CD stuff, but I tried to focus primarily on development process-related stuff. I will go with an assumption. I think everyone here is either a software developer or somehow related to software development process. I think it's a pretty much accurate assumption. So we're going to talk about your security bugs, a bit about supply chain attacks that are targeting developers' machines, a bit about dependency confusion, resource tampering, and some problems related to disclosed and undisclosed third-party software vulnerabilities. But man, it's a good moment to be in the JavaScript community. Last month, that there has been more, actually 2 months, I think. 2 months worth of my work. It's that many packages that got either compromised or were built for malicious reasons. And it happens every single day. So for the last 2 months, there weren't a day where we wouldn't report something security related to NPM. There are many things. I don't know if you keep track of the recent attacks. This is one of them. User agent parser JavaScript. The malicious actor published some cryptocurrency mining code and bot code that works upon install. A really cool one because they use an ATO attack before. What is even more interesting, they did research on how to bypass NPM security systems. Before that, NPM is not the best with the reaction time on stuff. So there are malicious security researchers researching NPM, especially during the weekends. There were a couple, well, more than a couple, libraries that would focus on stealing environment data. And those ones like that, really cool, obfuscated stuff. I mean, it isn't far away from normal JavaScript for me, but and some Windows obfuscated scripts as well. And yeah, and this is my mailbox on a busy day. So I pretty much spend a lot of time reporting stuff, and what is really bad, I tried to reach out NPM about it. They blocked me on an Nginx level after 20 reports. For an hour, I get 4 to 9 too many requests, and I'm not even like in the middle of reporting. And as I said, 60 to 80% of your software is built by other people you don't know, people you don't care, but people you expect to fix bugs ASAP, please now. And open source became a really good attack vector for malicious actors. There are many ways you can attack. You can use open source software as a mean of getting into a company. I'm briefly going to mention a couple that are mostly related to the development process, not production. Oh, I did a typo. OK, anyhow, some of the risks here may not directly affect you, but may affect your company's customers. And it's worth keeping in mind. And I know that not all of you do backend stuff or client SDKs for other companies, but it may turn out that your company is providing SDKs or other libraries to use. They also may be a really good target, and your customers may be, because you may be really good with security, and malicious actors do compute return on investment, but maybe your customers aren't. So it's sometimes worth keeping them in mind as well. One that is used widely for attacking customers of your customers is something called brandjacking. So malicious actors build up fake libraries, sometimes even making the SDKs work, but with some extra code in them. And when they publish stuff to registries, not only NPM, but others, they try to leverage inconsistent namings in between platforms. So you can try guessing, or you can check who owns this in Ruby Gems, or this, or who owns that for JavaScript. That's me. And I did some investigation on how often it is being installed and a couple other things. You can get really far with that. So if your company has a GitHub account, please make sure you basically book all of the names in all of the registries, even in registries in which you don't plan to provide any types of functionalities near term. It's better to take it and keep it. I know it's semi-legal based on NPM terms and conditions, but I think you can figure that out with NPM. Otherwise, someone may take it and use it to exploit stuff. And this relies on the fact that developers are lazy. I'm lazy. So I go to GitHub, I check the name, and I don't do it anymore, but I used to do it. And I just install stuff and try to play with it. I don't read all of the README and look for the exact name of a library, because sometimes you have a GitHub GitHub project that aggregates several SDKs or something. I don't do it. I just pick the name and go with it. I used to do it. I don't do it anymore. And what is really interesting about this and a couple other attack vectors is that registries provide you with enough data to do a really good data mining. So you can pretty much download all of the NPM public data using their replica. It's like 60 gigabytes of data, 15 or 16 terabytes to download all of the packages. And you can mine the out of it to get really interesting stuff that you can later use. You can do the same with GitHub. You can do the same with PyPy, with Ruby Gems. You can start cross-correlating data for malicious purpose. You can automate all of this. You can start releasing packages with some malicious content that isn't active, to just see whether it's going to be detected by a given registry. This is how user agent started, and Koa actually as well. And there are things that I think are happening at the moment in a similar manner, because someone is just probing a given registries. And once you automate it once, it's pretty nice. On dark web, you can download the leaked credential data. You can correlate it with authors because they keep their emails in the source code, or registries provide you with contact emails to maintainers. You can do a lot of it in scale really fast, really fast. I mean, a couple weeks, and 1,000-2,000 computers easily. The next thing that happened, I think at the end of last year, was dependency confusion. Please raise your hand if you don't know what is transitive dependency. Great. Then just for the sake of recording, transitive dependency is dependency of your dependency, or dependency of its dependency, and so on. We're actually really simple. But what people don't know is that resolving dependencies is really hard. You can look into NPM source code and look at the algorithm, or for Ruby or for any other package registry client. It's complex. If you add more than one source and you don't have really strict version locking, there will be bugs. And this is what happened with the dependency confusion. Majority of package registry clients had some bugs in the resolution engines. And what that caused is the resolution engine to pick up a public package where it was supposed to pick a private one. It was supposed to pick a private dependency, and then it decided to pick a public one instead. And you can have anything in the public package that you don't control. We did notice that. I'm part of the RubyGems security team. We did notice what Alex was doing when he started the research. This is the day when he started publishing the packages. I pinged him that we know what he's doing. We allowed him to do it on RubyGems because of the RubyGems security policy that allows people to publish non-malicious research packages. I don't agree with this policy, but this is the policy of RubyGems. So this is how it happened. But there's one thing that people don't think about, especially when using NPM. I noticed that it happens for many, many packages in NPM. When you publish something to NPM, majority of people will just put their code there and ship it. Done, right? You build this funny package, you put it on NPM, you're happy with it, and some people may try to use it. Maybe they will. But as always, we're developers. We like to abuse stuff. So someone came with this idea that maybe it's not worth publishing all of the code to NPM. Maybe I can make NPM download my stuff when you install it. Why would you put all of the code in a package? It doesn't make any sense, right? It's better when you have to download stuff from GitHub or a bucket or any other place. People started doing that to build auto-updating packages, which is super cool. You release an update, and next time someone installs your package, they get the most recent version, right? You don't have to ask them to, hey, would you mind updating your package JSON log or your yarn log? They get the new content, right? It's like auto-updating. Some companies use this approach to ship precompiled assets, precompiled C code, for example, or to ship code that they don't want to put publicly. I have no idea why, but companies do that. And that is a really big problem, because whatever is being downloaded is mutable. Whatever is mutable can be changed over time. So we can inspect a package, and then in 2 weeks, there's something else inside of it. That's a really big problem. And one last thing that happened is copycats. And NPM is good with their policy. They're not good with enforcing it, but the policy is good. You are not allowed to publish anything that is of a research nature / malicious nature. It needs to do something, right? There needs to be a reason for a package to exist, and the reason needs to be valid. RubyGems does not have this policy, so each time there's a new security research, in a week later, there are like 25 people doing the same stuff. But on top of that, there are people that do malicious stuff, claiming they do research based on someone else's research. And that can be really confusing for security researchers, because you don't know if it's a security research or a malicious activity. And some people try to abuse that, making their packages stay in the given ecosystem longer. And as I said, recently it was 500 packages. And some of you may think, oh, it doesn't really matter. Majority of them are new packages. But what happened with user agent parser was simple. It was trivial. They placed the code within the package. It wouldn't be detected for days or even weeks if they would link a dependency. This is what they did poorly. If they would release a dependency that no one would look into, and link this dependency in a package, you would just go with it. Majority of people would just go with it. They wouldn't notice, oh, someone added a dependency, maybe they extracted it. You could name it similarly. Let's say user agent parser Firefox, whatever, right? Oh, they decided to split this library. It happens all the time. A new dependency, whatever. Oh, and the last one I reported was 31 minutes ago. Open source is a great way to get into your computers and your company supply chain in general. No one reads all of the code of projects they use. Projects usually start fresh. they fall behind, and then there's this, how do you call it, a week where you can do something and you start updating dependencies and so on. Every once in a while. Yeah. Usually when you have a dependency that basically you need to update because AWS is forcing you or something like that. Many of risks related to your software development process come from your dependencies. Not all of them, but many. And what is really interesting is that attackers are developers and they're lazy, so they compute their return on investment. And they look, if we're talking about attacking software developers' machines, not production systems, they want to gain as much as they can with no effort, basically. They try to do it that way. And open source is great to do it. And their primary reason is not always to hit production. It's becoming less and less of an issue to hit production because they're targeting software developers' machines, and they want to do that. When they steal your AWS credentials, Docker credentials, GitHub keys, they can elevate that, right? They can use the keys they stolen to inject their Docker containers, for example. Unless you're signing them, they can repack the data, put something extra there. Boom, we get a second SolarWinds, pretty much, right? If something like this would happen and would be used, it's not only your company that gets compromised if you ship your software as a container, but all of your customers would. That's the primary difference in between supply chain security and open source supply security. Your open source supply chain may be supply chain of someone else if you do open source stuff. And I don't know if you know that. I hope you do. Just running an install is more than enough to give all of the permissions to the system in JavaScript. So whenever you type npm install, someone else can run whatever code they want with the permissions of the user under which you're running your software. So if you don't use any type of isolation, you're just using your main user, you're just saying, hey, stranger, please, go with it. Do whatever you want. It's yours. And possibilities are endless. You can do a lot of cool stuff. If you get inside, I've seen packages that would infect other packages and would clean up them. So in case you would look into the package's code you downloaded, you wouldn't see anything malicious. Unless you would manually download a package without running the scripts, unpack it and install, and then inspect all of the files. So part one is done. It's becoming more and more problematic to use open source. And in general, it's becoming more and more problematic to do software development because of the damn security. Easy. You know who that is? That's Yoshitaka Sakurada, ex-minister of cybersecurity of Japan, and he said he doesn't know how to use a computer because he has people for that. They fired him after that. But his approach was quite good. They wouldn't hack him, right? But that was just as a joke. But you can try implementing many things yourself. And I put it here only partially as a joke, because what I noticed in JavaScript community is that there's a package for everything, including like 5 lines of code stuff. And you put a package that you do not control, and you rely on 5 lines of code that are like wrapped with 200 lines of boilerplate. And you're happy with it. Oh, I've got a function. So my advice is to really look what dependencies you're depending on, and sometimes just not to. The bad thing is there is no general solution that will tackle all of your problems. But one of the things you need to be aware is that you need to make security part of your software development process. And I do not mean relying on DevSec ops people post Git push. you need to shift left with your approach. You need to tackle CVE stuff when that happens. Obviously, you need to run an assessment, right? Whether something is important, how important can it be exploited, and so on and so on. But at least you need to be aware of problems that are reported. It's worth keeping in mind, though, that CVEs never include packages that were built for malicious purpose. So if you install something that and you hope that npm inspect will help you with that, if a package was built for malicious purpose, it will never get a CVE assignment. This is the CVE committee, whatever it is called, Mitra, I think, approach. It may change. There is a discussion on changing that, but for now, packages built to be malicious will not get a CVE issued. They will be removed after a given period of time from npm. It usually takes in between 2 and 5 days. But they will not get CVE. Yeah?
Yeah, so does this mean like ground squatting? If someone did that, CVE would not?
Yes, it wouldn't be there.
Okay.
So if you mine stuff and you go with branch jacking and you report yourself, after 5 days, npm will pick it up, remove it. They sometimes put a placeholder, like removed for security reasons. Sometimes they do not. I would say randomly, but they might have a reason for it. And if then you try to put a CVE reporting, it's going to be rejected because it isn't a bug. It was designed to be that way, right? So relying on npm inspect may not be the best because they may not have this data at all. Obviously, after it is being removed, you won't be able to install it. But at the same time, you will not know the reasoning why the package disappeared. Suddenly, your development machine or CI/CD breaks, and you don't know why. Oh, the package is gone, right? Sometimes you'll get a justification from the npm website, removed for security reasons or like blocked for security reasons. Sometimes it's just 404. For your software, use static application security testing tools to analyze your software for bugs. That's always a good practice. We all make mistakes. I make a lot of mistakes. So it's always good to have something like it. Instrument your code, because sometimes you can detect certain anomalies based on weird things happening in Datadog or whatever when you keep track of stuff. Unfortunately, stop relying on open source with this trust by default approach. Never. I did conduct some investigation before I joined WhiteSource. Anyhow, some people installed my packages, and I was able to reach them, and I asked them why. I mean, I had a big message. Please do not install it. It's for research purpose. I put a big message and post-install message. Please do not use it, blah, blah, blah. And I was able to reach out a couple people on LinkedIn, because I correlated their laptop names with LinkedIn data. And I asked this guy, a CTO of a company from Canada, dude, why? Why? Just this question, why? It turned out he's Polish as well, so there was additional word to it that I won't mention now. And he was like, if you don't know this word, just get me a beer after the talk. And he was like, well, I was just playing out with Bootstrap, and none of the libraries worked. So I listed all of them, and I tried one after another. It's like, yeah, great idea for a CTO of a 25-plus employee company. Great idea. But surprisingly, people have this approach towards open source. We're all friendly, we're all nice, The problem is, yes, we are, but sometimes there's an ATO or a malicious takeover. And when that happens, something hits the fan. You should use software composition analysis tools. You need to understand your dependencies and their dependencies, blah, 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 and so on. That's really useful to know what type of software your software relies on. If you're from a business side of things, it's really important to know the critical components, open source components, on which your business relies on, right? You need to know that. For Yarn users, use this. There is a interesting case. Do you use Yarn at all? Please raise your hands if anyone uses Yarn. Okay. I don't know how that works with NPM. I think it's a bit different because their resolution engine is a bit different. So there's corner cases in Yarn. Yarn install is supposed to be idempotent, I guess. Whenever you install the same log file, it is supposed to reflect with the same dependencies, with the same versions. There are corner cases. It may change. It may change also with Ruby. So what is really interesting is that you have a log file, but it can change. So Yarn install can actually act as Yarn update without you knowing that. So you go with this expectation, you build a container, or you deploy to production, you run Yarn install without this, and suddenly your production system or your CI is fetching a dependency that wasn't fetched by your computer. You end up with a different state. It may be a security issue, it may also be some sort of a bug, and you don't know where it comes from because your state on your computer is different than production. So always use the frozen log file. You can try removing the hooks. In the long run, it may not help you with all of the things, because if you run the software, it may anyhow do something, but it may break before you run it. This will remove some of the post-install or pre-install scripts that are being used to abuse systems. Keep in mind that it may actually break your system, because people use those hooks to download weird stuff from internet that seems to be legit. So you need to play with it and just check. Or you can run, I don't remember the command, but there's a command to cache dependencies in NPM. So they're local, and then you can remove internet and try to install them. And if all goes well, you're not dependent on post-install internet access. You may still be dependent on hooks, but you shouldn't be subject to data tampering. That's a general hint. If you have a bug, and it's not yet on production, but you don't know what the hell is going on, always investigate. Just understand the root cause. I'm not saying fix it, because, deadlines and stuff that needs to be shipped, even with bugs. But you need to understand what the hell is happening underneath the given bug. Be paranoid about user data. We all know that. Just, client-side validation may not be enough. Make sure that when you use sources for your dependencies, they're valid and legit. My friend did a research on RubyGems, actually, where he just bought domains, RubyGems and a couple others. I think it was like 200 computers in a couple weeks. People would just do typos when they defined the source of their dependencies, and they would go with it. He set up a proxy, so he would just proxy pass the request to RubyGems, and he could ship their own packages. It happens. We make mistakes, stupid mistakes like that. We do it. It happens. People do it. There is also the bits quoting case where the CPU shifts bits, but I wasn't able to exploit it for like half a year. I bought a lot of domains, and I got like 4 requests, so I wasn't able to chain it to actually make an attack. But I'm mentioning it that just so you know that there's something like this, and I don't think it's going to happen to you. Shift left. Again, don't rely on your CI/CD to notify you about problems, because it may be too late. The harm may already happen, and you may not be aware of it, right? Keys, credentials, cryptocurrency wallets, stuff like that, gone. Bring your own device is not always the best. I know people like to do it. I like to do it, but not always recommended. Obviously, watch out for typo squatting and branch jacking. That happens. What I noticed, though, is that it happens. Registries implemented some legit rules. They use Levenstein distance or a couple other algorithms to block similar names of packages. But attackers noticed that. So they, for example, add a postfix latest or something like that. They expand the names. So the Levenshtein distance seems to be big, but the package is still built to confuse someone. And I'm not saying it's going to confuse you because you came to a conference and you're really smart people, but there are people that you have in your companies, rookies, people that just started software development. They may not be aware of it. They may go to NPM, treat it a bit as a app store, you know, with legit stuff. They type something that you said, oh, just do React, and they see, oh, React, the most latest, you know, or something like that, and they go with it. Never blindly assume that someone owns something on the registry and that this someone is legit. It is often the case, but it's not always the case. Keep track of packages you have and how often are they being updated, are they being maintained? If they are not maintained, there may be a subject to malicious takeover. Again, you can mine this data. If you're interested about mining this data, I did a talk 2 years ago at RubyKaigi in Japan about that, based on Ruby gems. I think I found like 61 really good packages that you could take over that were really popular with millions of downloads, but they were unmaintained. So you could, you know, reach out to someone, use JSLint to pull request something, fake that you're interested in it, and then someone will give you access because you're a nice person, because people in open source are really nice. Once you have it, you make 2 legit releases, people get used to you. Oh, it's this guy, I've seen him. And then, boom, right? You submit a new dependency. You put on GitHub in README, so people are not cautious. You put a README, oh, yes, I've extracted this code to a dependency, blah, 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 you know. A single line change in the main package. You're there. You're mining cryptocurrency on someone else's resources. Never use new packages, never. Just, you know, if a package is younger than 7 days, just don't do it. Just don't go with it. No, end of story. 95% of problems off the table. The same partially applies to versions. But I'll get back to that in a second. If you see something unexpected, always report that to owners, to NPM, to pretty much everyone. Connect CVE reporting to some sort of a PagerDuty setup if you have one. Not all of the dependencies, I mean, not all of the severities, but the critical ones. It's really good to know about them because they can be used to, you know, again, data mining, exploiting stuff. You can compute the reverse dependencies of packages, then you can figure out the companies that use it, and then boom. Always run a proper assessment towards packages you plan to use. Maintenance, releases, bugs, people behind it, and so on. Adoption in the community, download counts, stuff like that. Even previous CVEs. If there are CVEs, it may mean that authors are security aware. They're open. They are not hiding their bugs, you know. They're open about publishing them and, you know, talking about them, which is much better than people that just hide stuff in random commits, you know, without telling anyone. What you see on GitHub and what is on NPM may be completely different. Completely different. And just keep that in mind, because people forget about it. You can see a legit version of a package on GitHub with a GitHub release, with changelog, all of that. But the content of it may be completely different from the one that you see, that you download from NPM. It may be just different package. If you use the dependency updating tools, I hope that, I don't know if all of them, but some of them should have an option to set a delay on updating. Again, 7 days, unless there's a critical bug and stuff like this, but you need to handle that somehow. Put a delay. Majority of stuff is being detected, or by me in like 20 minutes, but then reported and removed in, let's say, a day, up to 5 days. So if you set up 7 days, again, it removes part of the problem. Stop keeping everything in env. I know it's then software development may become cumbersome, but keep that in mind. If you put everything into environment variables and someone gets that, you may not even notice that, but your employee may at some point. Educate people that didn't come here. Always, especially people that start with working with open source stuff, that learn, that aren't as senior as you guys are, because people make the majority of mistakes. Please never do it. Never expose your project's open source dependencies publicly. DHH, author of Rails, did it. He was like, oh, here's our beautiful gem file with our Ruby dependencies. But based on that, you can figure out their internal naming conventions of their packages, and you can try exploiting things like dependency confusion. Now you know the naming conventions. You get knowledge, right? Don't do it. Don't be that open to everyone about, I know that security by, how do you say it? Security by what? Obscurity. Yeah, security by obscurity is not the best. But you don't need to provide additional insight for malicious actors to work against you, right? Without a valid reason. Use containers if you can. Docker containers are decent, unless there's a bug in the kernel. But if there's a bug in the kernel, probably someone that discovered that is going to do better stuff than trying to attack your developer's computer. And it should help you with a lot of stuff. Yes, they may still steal your source code, but so what? No legit company is going to buy it. Without business knowledge, without experts, it's almost useless, aside from certain algorithms and stuff. But even then, you need people to work with it. So Docker is pretty good with that. I know it's not the easiest technology to start, but once you have it, it's really good. If you decide to review stuff, don't go to GitHub, GitLab, whatever. Just download the package from npm, unpack it, check it. You can use Defend, because Defend is provided for free to basically check any package on npm or Ruby gems in between versions. So if you're interested what changed in between version 1 and version 2, you can just put it on the UI. And if you trust me, I'm going to download both of them from npm and compute the diff for you. Although keep in mind that, I'm me. So as a summary, trust no one. Keep in mind that if you're updating something, you need to know what you're downloading. Track changes in between releases. Use Docker. Be aware of what you have in your environment. If you have a CI/CD pipeline, use separate stages in which you put only the environment variables that you're interested in. I'm going to publish that online later. So align your security flow to match your organization, depending on the type of data you have and customers and things like that. Shift left, which means keep in mind that your computer may be also a vector for an attack. The attack may be not designed to reach production. Someone may be just interested in your computer or its data. And yeah, I'm exactly on time. Thank you. Any questions?
How does NPM audit fit into the best practice?
So NPM audit downloads CVE data from NPM. NPM fetches that from GitHub and I think a couple other sources. But it's gonna, I should mention that, that's true. But I did mention the CVE stuff. So it's gonna tell you about the known vulnerabilities, right? most of the stuff that I would call critical in terms of account takeovers, malicious takeovers, cryptocurrency mining, data stealing, that's pre-CVE. Once that's in CVE, in 99.99% of cases, it's also already removed from the registry, so you're not going to install it. You will get the knowledge that you were exploited if you have it, and if it's cached, because if it's cached, it's not going to be fetched from NPM again. So you may get this knowledge, yes, but the harm already happened. Now you need to think how you're going to tell that to your boss.
It's too late by the time you run that.
Well, you know, if you want to change a job, that's exactly on time. So up to you to decide. But no, just it won't notify you about the things that aren't published to CVE. And I did try to publish stuff to CVE a couple times, and it's a cumbersome process unless you know people that know people. So I gave up on that, and I do not report stuff anymore. And I know people. So yeah. One last thing worth mentioning. There's a change that is going to happen, so even if you do not care and you just came here to sit for an hour, it's going to hunt you. Because Biden issued an executive order on improving the nation's cybersecurity, which means that if you're going to work with government or produce software for governments in a year or maybe faster, you will have to comply. You will have to provide SBOMs, which is software bill of materials, which is the list of your open source, their dependencies, people that are behind it, and so on. And you will have to comply with other regulations. And I think that what is going to happen is the same thing that happened with GDPR, right? Government introduced it, like European Union introduced it, and then other countries follow along. So the same is going to happen the other way around. US started with cybersecurity. Other countries will catch up, and then the business will catch up. If the government requires SBOM, I'm going to require SBOM, right? So sooner or later, you will be forced to deal with that as a software developer. Is that good? In general, yes. It may block some of the open source development because it may no longer be that easy to include new open source stuff or you know, crazy libraries, let's say that way. Hype-driven development may not be that easy. But in general, it's going to hunt you.
So I've noticed a lot of vulnerabilities when that are associated with the dev dependencies, and that pruning my package before I publish it in NPM, all getting reduces the size of it, which is great, but it also eliminates a lot of code that my code doesn't need to run at runtime. It's only there for dev dependencies. Have you ever seen any vulnerabilities related to dev dependencies or some of this other monkey stuff that might happen with post-install scripts or anything like that? And is it a best practice security-wise to prune your packages, or does it matter at all? Have you ever seen any
So I can say from Ruby gems. I've seen. But in Ruby gems, you can define the dev dependencies separately. And when you build a package, they're not being included in the final release. I don't know how it works in NPM in details, but if it's removing the dev dependencies, that's great. The less dependencies there are that are useless, the better. In terms of branch jacking and typo scoring, yes, some of the I don't remember the name now, but some of the JavaScript libraries that are used for testing were subject to attack. Sometimes attackers take a package, they automate that, so that's super cool. You know, NPM blocks me, but they don't block someone from releasing 100 packages in an hour. Makes perfect sense. What I noticed that they repack the packages. So they take a package, they repack it, they put their malicious code, they pack it back. So when you open up a website, you see a legit thingy, right? You see a good reference to someone else's package, you see the README, you can follow the links, and then you go to legit GitHub of the project. It looks good. The content is there. It provides all of the functionalities. Well, aside of this extra line with all of the malicious stuff. So the less dependencies you have, the better. If you're releasing stuff to NPM, I can give you one more advice. Remove everything that is not production related. it will, if it's not gonna help you, it's gonna help me, people that review stuff, because what people tend to forget when they publish packages, they keep like NPM node modules, for example, right? It drives me crazy. Because all of the automated tools that I build in Defend, they start, pinging me that something is there, but because there's like one gigabyte of uncompressed data with a lot of really complex software that shouldn't be in a package because I track package behaviors and stuff like that. So just remove all of that. If you have tests, do not publish them. No one runs tests based on the package content. Just keep production stuff there, unless you're releasing packages that are being used in Linux operating system. I know they run tests based on the package data, and then it needs to stay. But if not, just keep it to production-only stuff, and don't obfuscate. Don't minimize. There are tools in JavaScript ecosystem that people can minimize the code by themselves. It is also really helpful for security researchers not to have to deal with minimized code, because then I need to build an AST of this minimized code. I need to build an AST of non-minimized code. I need to compare it. I need to get the diff of it, and I need to make sure the content is the same. If it isn't the same, I need to figure out the changes. You just make my day miserable, pretty much. So please don't. And I'll get you a beer if you do. Thank you.